Hello students, today we are going to do chemistry. That is, you should know what are the chemicals which you see around. You come across many chemicals. Now, for example, when you put salt in the food, that's the chemical. That's sodium chloride, the chemical which goes inside your body. Sugar, that's the chemical. You yourself is a chemical. So various chemicals are going to get mingled with the chemical we are. Some would be useful, some would be harmful. So you should know various substances which are present in our environment, which are present around you, and how it works. So let us start from the simple elements, and more elements you study. How many elements are present in the environment, how you get to use those elements, and how they form compound. You have to study this in this chapter. So now element, compound, you have to know the symbol also. Internationally, symbol is given to that particular element. Why that symbol has been given? Because you cannot use the full word for chemical reaction, because you will forget that chemical reaction with that big word. So symbols are given which you have to study. I'll teach you. First, let us start. What is matter? Matter, anything that occupies space is matter. You have already studied that. So we start from matter. It is divided into solid, liquid, gas. Now solid examples, you already know: salt, sugar, and many more examples you'll see around. That is solid. And then liquid, water, oil. Now salt is different from sugar because it's a different chemical. Salt is sodium chloride, sugar is CHO, carbon, hydrogen, oxygen. So they are completely different. And then again, the chemical composition of water is different from oil. They are not same. Their state is same. Here the state is same, but the chemical composition is not same. Now gas, air we breathe in. That is the homogeneous mixture of oxygen, carbon dioxide, nitrogen. They are present in a definite proportion. So gas you will study. Now this matter can be divided into living and non-living. Living, we all are living, so that is in bio. You study that in bio. You need not bother what is there in the bio right now. We study what non-living will consist of. So non-living, that can be natural or it can be man-made. It can be natural or it can be man-made. What you find in nature? Like in nature, you find various elements. Iron you find in nature. But plastic is man-made. So many things which we make, humans make, that is man-made, and which comes from nature is natural. So natural and man-made. Then there can be pure and impure substance. Now mixture, when you say mixture, have you eaten poha, chuda? Any chuda you eat, that's a mixture. Because you can pick up the singdana, eat, poha you can eat, you can individually separate. That's a mixture. That's not a compound. And that is forms a mixture because they are just put like this. Supposing you have any sharbat, that's also a mixture because sugar is mixed in water. There's no chemical reaction taking place, then it becomes a mixture. Now, this mixture can be homogeneous and heterogeneous. You have to understand what is homogeneous and heterogeneous. Homogeneous means uniform. एक जैसा होना चाहिए. That is homogeneous. When it's different, it is heterogeneous. So, supposing I put the cubes of salt and sugar together, that's a mixture. I can separate. But if I crushed both of them and mix, then it becomes a homogeneous mixture because the structure becomes one. Homo, uniformity. There's a uniformity. And when there are cubes, it is heterogeneous because it is different. So homogeneous can be of pure form, only one salt, they are same. So you call them as homogeneous. Try to understand the meaning. Homogeneous, there will be one substance or some other substance which looks like it. They become uniform. So they become homogeneous. Heterogeneous, they will be different. So I hope you have understood of this homogeneous, uniformly mixed, heterogeneous, non-uniform. And here mixture, impure, and mixture will be impure. Mixture cannot be one, no? So it is not pure. It will remain impure because it's a mixture. Mixture means 2, 3, 4, 5, many things coming together. So impure substance which will be homogeneous, uniform. Here also you can see homogeneous, uniformly mixed, heterogeneous, not uniform. You have to understand up till here. Then you have to understand pure substance. Pure substance, what it will consist of? It will consist of element and compound. Now what is element? Element is just one substance. You break, one atom of the element will also have the property as the big one. So it is form of similar structure, atom, that will become an element. You take example of iron, which you can see with your eyes. You see iron things around. So iron you use for various purposes. That iron, if you just go on breaking, one atom, that property will be similar to the big iron also. Why? Because it is pure iron. But if I add some impurity, then its property will change. If I take gold, pure gold, its property, that being shiny, all those properties will be same for one atom also and many atoms also. That's pure gold. So purity is something only one. But air you cannot say it is pure because it's a mixture of oxygen, nitrogen, carbon dioxide. But if you separate oxygen, then it's pure oxygen. So people who are sick, what they do? They put oxygen in the cylinder and give oxygen because you require oxygen. Your lungs are not able to differentiate carbon dioxide and nitrogen and nothing. You require pure oxygen because your lungs are not healthy enough. That is pure. Okay. So here elements and compounds. Elements will be only one. Gold, iron, they are one. But if you take salt, that's not element, it's compound. Compound by two elements, sodium and chloride, they'll combine and they'll form salt. So it's compound. But again, compound they have become very attached. They are one thing. Their property will they'll form a molecule. Two atoms combined, they'll form molecule. They are one. They won't be able to separate now. Now if you break salt, one NaCl, sodium chloride, will have the properties of many sodium chloride, many molecules of sodium chloride. So that forms one entity, that's the compound. You will understand better as we go. You'll understand what is compound. These are the things which you see. Water is the classic example of compound. How it is formed? By two gases, hydrogen and oxygen. They combine to form water. So which are the elements which have been taken? Hydrogen, oxygen, and they are both gaseous. But when they combine, they become liquid at room temperature. And because any substance you take, they can be converted into solid, liquid, gases with variation in the temperature. But when we talk about solid, liquid, gas, it is on the room temperature. The temperature which we are living, the state which they are in, we talk about that. So here elements, compound, I hope you have understood the difference. The elements can be metals, they can be non-metals, they can be metalloid, they can be noble gas. We'll see this variation as we go. So let us just revise. This pure substance will be uniform. If it is pure element, then it is pure element. If it is pure compound, it is pure compound. But they will be uniform. They will have a definite composition. Hydrogen H2, oxygen O2, but they become water, then H2O, but it's a definite composition they will have. Physical and chemical properties will remain same. One atom, many atoms. Physical properties or chemical property will remain same. And supposing you take water. If you take from the freezer, it is at 0 degree, it is in solid state. But if you heat, then at 100 degree, at room temperature it will become liquid. At 100 degree it will become vapors. This is what you can see about water. But if you carry for any other element also, if you vary the temperature, they will also behave in the same manner. So melting point, when they melt, and boiling point, when they boil and turn into vapors, that will be same. And pure substance, so hydrogen pure substance cannot be broken. Oxygen pure substance cannot be broken. When they combine to form one pure H2O water, they cannot be broken into simpler form. Cannot be broken into simpler form. So this is the properties of the pure form. And supposing you take water, 100 degree it will evaporate, 0 degree it will freeze. But if you take some salt and add in the water, then the freezing point will vary depending upon the salt you have added. And if same way, for evaporation, if you have added salt, it won't be 100 degree. It will take more time, more than 100 degree. So their melting and the boiling point will vary when you add impurities. Pure, it will remain definite. But impure, it will vary depending upon the impurities. So next we'll study more about the elements. Now elements, what is the definition of element? It's a pure substance which cannot be broken into any simpler form. That's the simplest form of any substance, that is the element. That's the element. Now, as the number of element is definite, as the number of alphabets in English, 26, that's definite. Even the ka, kha, ga is definite. So the alphabets, as they are definite in number, same way the elements, they are definite in number. But how do we have so many substances around? Because as number of words are formed from those alphabets, same way number of compounds will be formed from those elements. Elements, they are definite in number, they are few in number. So how many are the elements? We know 118. Scientists, they have discovered one by one. So right now how many we have? 118 elements. So are they all natural? No. 92 they are formed in earth. Earth, all the elements we get from the earth only. But scientists have created few more. So artificially made are 26. Now, what do you think? Where all these elements have come to the earth? How we have been formed? You must have heard about the Bang theory. According to the Bang theory, the star has had the element in their heart, and when they bursted, they distributed these elements, and then we have been formed, the earth have been formed, and all those elements have come from there. That's the theory. If you accept, well and good. But you have to know how many are there right now? 118. Scientists have discovered them. So maybe in future you'll have more elements discovered by scientists. 92 you find from the nature, from the earth, and 26 have been artificially created. So let us study the element which are the purest form. You cannot break the element into simplest now. They are purest, and if you break also, they will be same as the element only. Now in general, the element can be metal. What you see around is metal and non-metal. And then some are having property of both metal and non-metal. They are metalloid. दोनों का प्रॉपर्टी है, मेटल्स का भी नॉन मेटल्स का भी. So they are metalloids. This many metalloids are there. And then noble gases. Why they are noble gases? Because they won't react with any other substances. They won't react with anyone. They'll be noble. So since they don't react, they are known as noble gases. So these are the examples of noble gases: helium, neon, argon, krypton, xenon, radon. Metalloid: boron, silicon, arsenic, antimony, germanium, tellurium, polonium. ये सब कंठस्थ करने. You have to by heart all these names. You cannot, once you have understood this concept, memorizing the name of this metalloids, you have to memorize. This noble gas, you have to memorize. And now, metals and non-metals which you see around, that you will slowly learn, and the memorizing will take place automatically. But this you have to memorize. You have to make efforts to memorize this metalloid and this noble gas. Now metals, let us see the difference between the metals and non-metals. As you see, metals will be very solid, very hard, very strong. Whereas non-metals, they won't be so strong. So you can see that it is shiny and lustrous. What metals? You take gold, they will be shiny and lustrous. You can see the gold is shining. But if you see some non-metal, that won't be shiny. So here they will have, metals will be shiny and lustrous. But again, there will be some examples of metals which are not shiny and lustrous. Sodium. Sodium is not shiny and lustrous. Then again, here in non-metal, some will be very shiny and lustrous. If you see the cubes of the iodine, it will be purple color, blue color, it will be shiny and lustrous. And carbon is a non-metal. Carbon is a non-metal, but it has the capacity to form diamond. It will form diamond. Where you find diamond? Where you find coal, there you find diamond also. And you will see that diamonds are the most shiny, lustrous structure. So, carbon is a non-metal, but still when it forms diamond, it forms graphite, it will change its property. Diamonds are the hardest substance on this earth. So, few exceptions, but in general, these are the properties of metal and this is the property of non-metal. So, here it will be shiny, lustrous, dull, non-metal dull, except iodine and diamond. Diamond is carbon. It has carbon, carbon, carbon. The position of carbon is such that they form diamond. So where we find coal, we find diamond also. Diamonds are shiny and lustrous. Okay. They are all, metals are solid. Metals are all solid. Whereas non-metals, they might be solid or they might be gas also. But metals, mercury, you have seen thermometer, how you measure your temperature with the help of thermometer. There is calibration. You know whether you have a fever or not by putting in your mouth or underarm. You see the calibration changing from room temperature to your body temperature. This is how you find out what temperature your body has at that moment, and mostly it is used during fever. So what is present inside the thermometer? There's a liquid. There's a liquid which is mercury. Don't break the thermometer to see this mercury. It is poisonous and it should be well handled. So mercury is the liquid which expands on heating. Slight heating also it expands, and due to its expansion you are able to read the calibration of your temperature. So this is how mercury, exception of metal which is in liquid state. Then metals can be made into wire. So that property is known as ductility. Metals are ductile. Wire में बना सकते हैं. Copper के wires होते हैं. The one which is conducting electricity is copper. But why we are able to do that? Because we have the property of becoming wire, very thin. very thin. Some wire can be so thin that we won't be able to see like this. We have to see under microscope. Anyway, ductile means very thin wire. Non-metals, they cannot be drawn into wire or beaten into sheets. Malleability is, you just make it very thin. You have seen that chandi cover over sweets, that is silver beaten into very thin. You can eat. You'll enjoy that attraction of orange color sweet with silver foil covering it. That makes it very palatable. You feel like eating. That's because silver is a metal and it has the capability of being beaten into very thin. That property is known as malleability, malleable. Ductility, very thin wire. Malleability, that is very thin sheets, very thin sheets. Now again, ductility, malleability is not for zinc. Zinc is a metal. This is exception. It's a metal, but it won't be made into wire. It cannot, because it will break. It's brittle. Zinc. So it is not having the property of metal, even though it is metal. Malleability, zinc will break, brittle. So no, not malleable. So here this is the difference between the metal and non-metals. They are good conductor. That is why we make wire of copper, because they are good conductor. All metals are good conductor, but copper is more viable. So use as conductor. Good conductor of heat and electricity. Heat क्या? चलनी heat हो जाएगा. So metals are good conductor of electricity. Now the example which is not having this property is tungsten. Same way, here they are bad conductor of heat and electricity. But then again there is a exception, which is graphite. Graphite is what? It's carbon. Carbon फिर तगड़ा हो गया. So that is graphite. It's not metal, but it will conduct heat, it will conduct electricity also. Very high melting point and high boiling point. आयन को हीट करने के लिए, मेल्ट करने के लिए बहुत हीट करना पड़ेगा. 1500 से भी ज़्यादा करना पड़ेगा. So metals will have very high melting point and boiling point. Melt करने के बाद फिर boil होके evaporate होने के लिए, that will require very high temperature. So they have very high melting point and boiling point. पर इनके पास non metals के पास बहुत जल्दी मेल्ट हो जाएंगे, जल्दी बॉयल हो जाएंगे. So melting point and boiling point is very low. Then sonorous substances. अभी sonorous means what? It can produce sound. We will do like this, tuck 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 tuck. This is a sound which will be produced in metal. This is not metal. This is metal. Anyway, metal will produce sound. Non-metal will not produce sound. So this is sonorous and this is non-sonorous. So that ganti which you can make of metals, that is why it will produce sound. If we do like this, then sound. For metal, not for non-metals. So they are non-sonorous. Sonorous will produce sound. Non-sonorous, it will not produce sound. So this is what it is about, the element, metals and non-metals. This should be clear in your mind. Nothing should deviate you from these properties. We'll just revise again. And the names of metalloid and noble gas have to be memorized. You cannot, you have to memorize anyway. So here let us revise the difference between the metals and non-metals. And here you can see number of elements. 20 elements which you have to study. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These are the elements which you have to know. We'll study the symbols. Now next, after understanding this, you have to understand the symbols. Now as you go high in chemistry, symbols very important. Then you will know, you learn the chemical reaction. If you don't know symbol, chemical reaction, you won't understand. So here, with this understanding, let us just revise it. Boiling point, high for metal, low for non-metal. Melting point, high for metal, low for non-metal. Conductivity, it's a good, metal is good conductor, whereas non-metal is not a good conductor, so bad. Density, it is very high. Again, density is what? If you take iron, it will be very dense, you'll feel heavy. Whereas oxygen you take, you won't feel density, or iodine, you will not feel the density, whereas the density is more in metals. Shiny, metal; dull, non-metal. Malleability, metal malleable, non-metal non-malleable. Ductility, metal ductile, non-metal non-ductile. State is solid, here it is solid and liquid. Here again solid or gas in non-metals, but there is a chemical name as bromine. Iodine का भाई, iodine solid है, लेकिन bromine is what? Liquid. It is a reddish color liquid which is used for various chemical reactions. So this is an exception. It is liquid. Rest of them are solid or gas, but bromine is liquid. This is the exception. Here mercury is the exception. For malleability, zinc is the exception. For being shiny and lustrous, sodium is exception. For being good conductor, tungsten is an exception. And here being bad conductor, graphite is an exception. So few exception also you have to understand and remember, because that will come for your fill in the blanks or for writing the answers. So now we go for studying the symbols. So after this we'll study the symbols. Now to study chemistry. The scientist Berzelius, he gave symbols. He gave symbols to the elements. Why? Because then the chemical reaction will be easy to write the chemical reaction. So Berzelius, what name he gave, what symbol he gave to the oxygen? What symbol he gave to the oxygen? O. Whatever the initial alphabet, he gave that symbol to the element. O. Hydrogen, H. Carbon, C. Now see, carbon, C. Calcium, he could not have given C to calcium. So what he gave is Ca. Cobalt, again CO. C, Ca, CO. Now copper. Some names. See, this discovering of the element and arranging the element is a slow process. So many scientists have given their input, and some scientists they have given scientific name in Latin. So this derivation of this symbol have been from the Latin name. So your copper, the Latin name is cuprum. It is cuprum. So what is the symbol? It is Cu. Cu is the symbol for copper. Iron, ferrum. Therefore the symbol is what? Fe. Ferrum, Fe, cuprum, Cu. That is for copper. The Latin name is cuprum, therefore Cu. For iron is ferrum, therefore Fe. Cobalt is in English Co. Calcium, Ca. Carbon, C. Hydrogen, H. Oxygen, O. So this is the general symbol which are given to many elements. Hydrogen, He, helium, He, lithium, Li, beryllium, Be, boron, B, carbon, C, nitrogen, N, oxygen, O, fluorine, F, neon, Ne, sodium, Na. Now this sodium is from S, but the name is given from N because it has been derived from the Latin name. Magnesium, Mg, aluminium, Al, silicon, Si, phosphorus, P, sulfur, S, chlorine, Cl, argon, Ar, potassium, again potassium is from P, but the symbol is given from the Latin name K. Calcium, Ca. So these are the symbols for the 20 elements. You have more elements to study, but right now we start with this. So symbols, short, they are abbreviation. Abbreviation is what? Short form. Initial alphabets are used. Like for UN, United Nations. Initial symbol alphabets are used. That is known as abbreviation. So what we are doing? We are using the initial alphabet. So that is abbreviation. So now this symbol's short form that represents an atom of a specific element. The symbols, when I say calcium, that is the atom of the calcium. Cobalt, atom of the cobalt. Cu, atom of the copper. Fe, Fe is atom of the iron. So when we use this symbol, that is, we use the atom. We mean the atom. So when we are writing the equations, the chemical reactions, we are doing with the atom. Now this atom will form compound later on, but we are doing with the atom. So symbols we are using. Scientists have been studying on this, and scientists have made a periodic table. Why periodic table has been made? There are so many elements, but they have been studying their properties, and what they have found, they have arranged the element according to the atomic number, atomic weight, atomic number. What they found, the properties are repeated. When they are repeated, like how when you sing the sur, sa, re, ga, ma, pa, dha, ni, sa. So every eighth element repeats its property. You start from sa and again come to sa. Sa, re, ga, ma, pa, dha, ni, sa, sa. That is repeated. So same way they found in the element also. So they have prepared a periodic table because properties are repeated. Here they form the period. This horizontal and vertical. Horizontal is period, whereas vertical is group. So you find the elements which are in the same group will have similar properties. They'll have similar properties. Here you can see 0, that is the they are the noble gas, helium, neon, argon, they are the noble gas. So this is the periodic table. You have to understand this is part of the periodic table. So these elements are arranged in group periods, that is the horizontal, and vertical, this is the group according to their atomic number they have been arranged, and they'll have properties repeating, and therefore known as the period. You'll be studying in detail later on, but you have to understand in universe you find hydrogen and helium. In sun also you'll have helium burning continuously. Earth's crust, which elements you'll find? Oxygen, silicon, aluminium, iron. These are found in the Earth's crust, more in amount. As such, all the elements will be there in the Earth's crust, but these are more in number. Same way, universe, many elements will be there, but hydrogen and helium more in number. Sun is helium gas burning continuously. Atmosphere, 78% atmosphere is nitrogen. Oxygen is only 20%. ऐसा क्यों है? If it had been 100% oxygen, everything would have burned. So be happy, it's more of nitrogen, that is 78%. Human body, we are also chemical, we are made up of elements. So which elements are more in number? Carbon, hydrogen, oxygen. The human body has got carbon, hydrogen, oxygen. So this is the symbol and the element arrangement into the periodic table. So now next we'll see how compounds are formed. Now how are compounds formed? As you form many words from the alphabets, A, B, C, you form number of words from these alphabets. So same way, the number of elements is fixed, you form number of compound from those elements. And same way, from 0 to 9, 1, 2, 3, 4, 5, 6, 7, 11, 1, 1, 21, 31. So with this 0 to 9 number, you can find number of digits. Same way for the element also, for the compound also, number of elements, you can form number of compounds. Slowly you will study. So they are the building blocks. Elements are the building blocks which forms compound. compound. Atom is the smallest unit which will form molecule, and molecule can be many types, many types. So at the start you learn about the few compounds. Now few compounds, classic example, water, you drink every day, it is from hydrogen and oxygen. Marble, the flooring marble, white color marble is calcium carbonate, that's a compound. Glucose, the one which you can, glucon D also, it's a glucose that will have carbon, hydrogen, oxygen. Sugar, that also has carbon, hydrogen, oxygen. Remember, they have carbon, hydrogen, oxygen elements are same, but their placement is such that they will differ in their properties. You'll see in many examples. Salt is sodium chloride, which you eat every day. Sodium is a metal, chlorine is a non-metal. Sodium, if you eat like this, you will die. Chlorine, if you inhale, you will die. But when they combine together, then their properties completely become different and you eat every day. But separated, they are very harmful. Together, they are very beneficial. Alcohol, again carbon, hydrogen, oxygen. Alcohol, most of the medicines are based on alcohol. Carbon dioxide, you give out carbon dioxide when you exhale. Calcium oxide, again it is used for putting tuna on your walls. Nitrogen dioxide, it's a gas. Zinc chloride, again it's a compound. These are examples of compounds. They are pure substance formed by the chemical combination of two or more elements in a definite proportion by mass. Right? Yes. One more thing you have to understand. Mixture you can put, if you can put the mixture of iron and sulfur, you make iron into very minute powdery form, sulfur powder you put, there will be mixture. No chemical reaction will take place. But moment you heat them, chemical reaction will take place and the properties will completely become different. Iron, get attracted by magnet. If you move magnet, iron particles will get attracted to magnet. But after you have heated, you move magnet, iron is not going to get attracted because it is completely changed into ferrous sulfide, another compound. And chemical reaction takes place to form compound, and they will be in definite proportion. Now see, this water is formed by hydrogen and oxygen. They will be in the ratio proportion 1:8, as 1 is hydrogen and 8 part is oxygen. The chemical formula H2O, but by mass is that weight, it will be 1:8. So if you take water from Ganga or you take water from Niagara Falls, anywhere in the world, you come and check, the water ratio proportion will be same. And once they have combined, very difficult to separate. So here water is formed by hydrogen and oxygen. Sugar, carbon, hydrogen and oxygen. The sugar which you eat. Common salt, sodium and chlorine. Alcohol, carbon, hydrogen, oxygen. Ammonia is that bad smell which comes out from the urinal. It is nitrogen and hydrogen. Chalk, which normally teacher uses on the board, blackboard, is calcium carbonate. So it has got calcium, carbon and oxygen. Sand, it is silicon and oxygen. Sodium carbonate, soda, which sodium carbonate is NaCO3. It consists of sodium, carbon and oxygen. Glucose, carbon, hydrogen, oxygen. Carbon dioxide, carbon and oxygen. Nitrogen dioxide, nitrogen and oxygen. Calcium oxide, calcium and oxygen. Zinc chloride, zinc and chlorine. Now all the elements, here few compounds are given which they combine in the definite proportion. Hydrogen, oxygen to form water in 1:8. Carbon dioxide, carbon and oxygen 3:8. Nitrogen dioxide, nitrogen and oxygen in 7:16. I hope you understand what is ratio and proportion. That is in definite proportion. 1 part hydrogen, 8 part oxygen. That is by weighing. Now it's very difficult to weigh for us. The scientists will weigh. They have weighed and seen the difference of the weight. So here nitrogen oxygen 7:16, calcium oxygen 5:2, sodium chlorine 23:35.5. This number are not just given like that. The scientists have done research on it. They have weighed it and then given this number. Zinc chloride, zinc and chlorine 65:71. This is how compounds are formed in a definite proportion. They are not formed just like that, definite proportion. And once, so they form molecule. Now hydrogen, H2O is a molecule, CO2 is molecule, NO2 is molecule, CaO is molecule, NaCl is molecule, ZnCl2 is molecule. So they are one unit. They are in pure form. That one unit is pure form. So water is one unit, that's pure. But if you add salt, that becomes impure. So another compound you have added. Water, H2O, it is one unit. But NaCl you add salt, then you have added impurities. Some other compound will become impure. But that only one compound will be pure. They are pure substances formed by the chemical combination of 2 or more elements in a definite proportion by mass. Molecule, they combine to form molecule. It's the smallest unit of a compound. They have formed compounds are formed, and then the smallest unit of the compound is known as molecule. They have the H2O is a compound. One molecule will have the same property as the many molecules together. So they are pure form. Atoms of 2 or more elements in a definite proportion. The proportion is also definite. They are not imbalanced. Fixed ratio. Now for example, then you can say NO2, NO, nitrogen, oxygen there. Nitrogen, oxygen. But if it is NO2, N2O or NO, they are in different ratio proportion. Their properties will differ. Even for water, it is H2O. But another compound, H2O2, hydrogen peroxide is formed, the properties will be different. So, the combination will give them the properties. The combination is changed, the elements may remain same. But if the combination is, ratio proportion is varied, then the properties will vary. And it's very difficult to separate H2O, CO2, NO2, CaO, NaCl, very difficult. Let us just take the example of water. H2O. What is so difficult of separating hydrogen and oxygen? Very difficult. There more of chemical, it's not chemical reaction, it's electrolysis. Electro means passing the electricity. Now lysis is breaking. What do you have to break? Hydrogen and oxygen you have to break into 2. So breaking of hydrogen and oxygen into 2 by electricity, that is known as electrolysis. Electrolysis. They become again hydrogen gas, oxygen gas, having properties different from their element. Hydrogen will burn by itself. Oxygen will support burning, but what water will do? It will extinguish fire. So properties of the element very different from the molecule or the compound. Compound which has the smallest unit of a compound is a molecule. So elements, atom. Smallest unit of element is atom. Smallest unit of compound is molecule. So this atom properties will be different from the molecule which has been formed. So here you have to understand what is atom and molecule. So this is for now. I hope you have understood. And if you have liked this, if you have understood this, please like, share and subscribe. Bye bye students.